So given x, quantity x squared raised to 3. So this can be written as x squared times x squared times x squared. So this is the expanded form. Applying the product law wherein we are going to add the exponent. So 2 plus 2 plus 2 is 6. So this is 1, numerical 1 times 1 times 1 still equal to 1. Or instead of adding all the exponents, you can also multiply directly 2 by 3. 2 times 3, that is x to the power of 6. So we have the same result. This will lead us to another law of exponents. So aside from the product law of exponent, there are other laws of exponent that are applied in simplifying polynomials. So these are the following. So power of a power law. If we are raising a power to an exponent, you multiply the exponents. Again, this time we are going to multiply the exponent. Why is it called power of a power law? Because a power 4 is raised to another power 3. So instead of writing this in expanded form that x to the power of 4 times x to the power of 4 times x to the power of 4, why not multiply it by 4 times 3? That is 12. That is also the same as 4 plus 4 plus 4, that is equal to 12. So that is the power of a power law. We multiply the exponent. It's simply the short method on the product law. So the same also with number 2, that is 6 times 5, that is 30. Take note that an expression with an exponent raised to another exponent simply multiply the exponents. So this time, we only multiply exponent if it is power of a power law form, meaning a power raised to another power. But if it is not, then we are going to add the exponents of the same base, that is called product law. So I have also another law, which is power of a product law. If the product of the bases is powered by the same exponent, then the result is a multiplication of individual factors of the product, each powered by the given exponent. So meaning, if we have a product of x times y, take note, this is product of x times y, because there is no sign between x and y, raised to a power 4. In short, this is a product of a power. So they share the same exponent raised to the power of 4. So simply multiply each exponent by 4. So understood, if there is no exponent, it's understood with just 1. 1 times 4, that is 4. 1 times 4 is 4. So that is x to the power of 4, y to the power of 4. What is the numerical coefficient here? It is 1. So 1, do not multiply 1 by 4. Meaning 1, that is 1 times 1 times 1 times 1, that is equal to 1. For number 2, we have the quantity a cubed b squared raised to 5. So multiply 5 by 3 and multiply 5 by 2. That is a to the power of 15, then b to the power of 10. Still, the numerical coefficient here is 1. So that is raised to the power of 5 is still 1. The result is 1. Now, for number 3, since we have already the product of 3m and n, so that is 3mn. So raised to the power of 2. Do not multiply 3 by 2 because 3 is not an exponent. Since we have understood that we have here 1 as an exponent of 3, that is 3 square. 1 times 1, that is 3 square. For m is 1 and n is 1, that is m square, n square. So 3 square is 9. M squared, n squared. So this is now the product. Do not add 2 by 2 because this is, we have different bases. Take note, do not multiply 3 by 2 because 3 is not exponent. Only the exponents will be multiplied. The same also with number 4. Do not multiply 5 by 3. Meaning that is 5 raised to the power of 3 because 5 has an exponent of 1. So 1 times 3 is 3. 2 times 3 is 6. 4 times 3 is 12. So therefore, the result of this is 125 This is equivalent to, take note, when you multiply, when you apply power of a product law, it is the same. It is like distributing the exponent. We will multiply exponent to the exponent of the given term. So that is 125 is 5 times 5 times 5x, and we have for y. So what is now the exponent of x? So the exponent of x here is what? 6, because you are going to multiply 3 by 2. That is 6. And for y, the exponent is 4 times 3. What is 4 times 3? That is 12. That is 12. So in short, the result for number 4 is 125 x to the power of 6, y to the power of 12. Take note, 5 raised to the power of 3. Do not multiply 5 by 2. This is a common error of the student, because if it is power of a product law, we multiply the numerical coefficient by the exponent. That is wrong. 5 is a numerical coefficient. Now, we all know that only the exponent will be multiplied or can be multiplied. So that is 1. Understood, if there is no exponent, understood that is 1. So since 5 cubed, that can be simplified. Why? Because it is constant. So that is 125. Let's have more examples. So there is 3 raised to quantity 3 square raised to the power of 5. By the way, when you read that parenthesis, that is quantity. A quantity of 3 squared raised to the power of 5. That is 3 to the power of 10. And that is equal to 59,049. So it is 3 times 3 times 3. So you are going to multiply 3 10 times. That is a to the power of 12, because we multiply the exponent. So it is understood this 1 as numerical. So 1 raised to the power of 4, that is 1 times 1 times 1. So the result is still 1. How about number 3? So do not multiply 2 by 3. It is understood that we have an exponent 1. So that is 2 cubed. Then multiply 2 by 3 here, the exponent of a. That is 2 cubed is 8. 8 to the power of 6. How about this example? So understood we have here an exponent 2 now. Unlike on number 2, we have only 1. So 1 times 3 is 3. So multiply, that is 2 to the power of 4. 5 times 2 is 10. 3 times 2 is 6. Then 2 to the power of 4, that can be simplified also because it is constant. For 8 to the power of 10, still, that is 8 to the power of 10 and b to the power of 6. But 2 to the power of 4, that is equal to 16. 2 times 2 times 2 times 2. Now, for number 5, that is a negative 3 raised to the power of 2. Do not multiply negative 3 by 2 because negative 3 is not an exponent. It is a base, or it is a numerical coefficient. That is 9. That is positive 9 because it is negative 3 times negative 3. 2 times, so that is 4. So that is 9a4. For number 6, we have here 1 as numerical coefficient. 1 to the power of 3, that is equal to 1. We have here 1. S is, that is 6. 2 times 3, then 4 times 3 is equal to 12. So therefore, the product is s to the power of 6, t to the power of 12. So it is understood that there is 1 here, or that is 1 s to the power of 6 and t to the power of 12. Take note that when you multiply, or when you simplify, we only multiply exponent if it is a power of a power rule form. Now, a product of a power rule, a power of a product rule or law form, but still you have to multiply the exponent. But if it is in product law, meaning they separated the two expressions, we only add exponents if they have the same base. So I hope you learned something with our discussion about the first 3 laws of exponents. So the first 3 laws of exponents that I have mentioned before in our slides, actually that can only be applied during multiplication. Now we will have another law of exponents for division of polynomials or algebraic expression. So later we will have multiplication of algebraic expression.